Welcome to the new cyber frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's new cyber frontier.
Welcome to today's episode of New Cyber Frontier. On today, we have Andrew Ginter, who is an author of the book Engineering Grade OT Security, A Manager's Guide. And by his count, it's pretty well sold. You said 22,000, over 22,000 episodes. So that is great, or books sold. And Andrew is also the VP of Industrial Security at Waterfall Security is his day job. But welcome today, Andrew. Thanks for joining.
Hello, Christopher, and hello, everyone listening. Thank you for having me. A clarification, 22,000 books in print, including my previous two. And they weren't all sold. We gave a lot of them away. So does that count? I don't know. I would like to believe people read a book that they pick up at a trade show, but who knows what the truth is.
All right. So we have to be honest, 22,000 minus 2, because they're behind it.
Okay, because you haven't read it yet. Yeah. So.
Anyway, so tell us about yourself. I mean, how did you get to the point where you are? What was your inspiration? Your path to being an author, and a little bit about what you did to get prepared for this.
Sure thing. So, where to begin? I spent about a decade developing industrial control system software products, historians, real-time databases, data acquisition, human-machine interfaces that are used to automate, power grids, pipelines, refineries, this kind of thing. I spent, 5 or 7 years developing IT/OT middleware product that connected a lot of OT networks, industrial control systems to SAP, to IT networks. And in the course of that connectivity, connecting industrial systems to SAP, my technology was an excuse for people connecting a lot of IT and OT networks, and thereby contributing to the cybersecurity problems that now plague many industries. I got religion. I wound up the chief technology officer at Industrial Defender, developing the world's first industrial SEM, security information and event management system. And now I'm at Waterfall, and I have the opportunity to work with the world's most secure industrial operations and learn what they do and write about it. And yeah, I've got 3 books. The first one, I've sort of wanted in the background of my career to write a book forever, and actually managed to pull it off in 2016, the first one. And what crystallized it really was a reaction to the first Russian attack on the Ukrainian infrastructure, turned the lights out on 225,000 people for, I think, between 1 and 6 hours, depending on the people. And some of the reporting for that in very prestigious sources was just wrong. And I said, and that crystallized it. I said, Andrew, write the shortest book that you can, so that if, who wrote this stuff? It was a staff reporter, so that a staff reporter cannot make this kind of mistake ever again if they've read the book. So that kind of crystallized. I really had no idea how to write a book. I knew how to write long blog posts, so I wrote 13 of them and called it a book. I called them chapters. And the second one was, sort of a reaction. I got really mixed feedback on the first one, in part because I was critical of a certain approach to cybersecurity. Nobody likes to be criticized. The second book, I swung to the other extreme. I said, journalism. Let's document what the world's most secure sites do differently. First they do this, then they do that. No judgment. If you, the reader, see any value in these techniques, you pick and choose. That was the black book, Secure Operations Technology. I documented a methodology. And the most common question I got was, Andrew, that's great, but when should I use each of these techniques? Because they look really good, but it's clear that they're not universally applicable. When do I need them? Where should I use them? And most importantly, why? Why here but not there? And so the third book, the engineering grade OT security, I swung back to the middle. Instead of criticizing, instead of documenting, I prescribed. I said, okay, Here's what the threat environment looks like. Here's what the solution environment looks like. If you have one of these, you have to do this first because of X. And then you've got a choice. You can either do Y or Z. If you got Y, then you should do, this P next because of Q, and so on. So that's how I got here.
Okay, well, great path. We're going to take a break, hear from our sponsors. We'll be right back to talk about what you can expect to see in this latest book. Be right back.
Blockframe Technology offers next-generation blockchain managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today, talking to Andrew Ginter, the author of Engineering Grade OT Security, A Manager's Guide. And that was a great intro to what made you write, where and how you got from your progression of the 3 books. And the latest, the prescriber's guide. So you became the doctor. You're making the recommendations, right? So let's talk about what it is that's in it. I mean, what's the content of your book? Let's give it from a high level. How do you approach your audience, and who would pick this up?
I think so. There were sort of 3 big chunks to the introduction. It is a manager's guide. I fly high and slow. I introduce industrial systems for people not familiar with them. These are power plants. These are everything from high-speed passenger rail switching systems to small shoe factories. And these are very different animals across this spectrum. And what in a sense determines the difference in my mind is worst case consequences of compromise. With a small shoe factory, what is the worst that can happen if every computer executes exactly the wrong instruction? Well, you might damage the equipment and have to, buy replacements. You clearly have to, somebody comes in and, messes with your system, you're going to have to bring in a gurus on an emergency basis, pay through the nose to have these gurus fly in and clean up the mess. You got to lay your people off for a week or 3 until the mess is cleaned up and the equipment's repaired. You have to bring your people back and pay them overtime to make up lost production. The whole thing is going to cost you what? $6, $8, $12 million. You can buy insurance for that. What's the worst that happens if high-speed passenger rail switching executes exactly the wrong instruction? Seconds later, trains collide, mass casualty event. You can't buy insurance for that. And even if you could, you can't restore lost lives from backups. This is the essential difference. This is the point I make in chapter 2. And, I explain what is some of the automation, how do these computers work, and why is it so different? Because if you're automating a passenger rail switching system, every change that you make is a risk, is a threat, is potentially going to malfunction and cause your worst case outcome because it malfunctioned. The engineering discipline for those very consequential systems, it's called engineering change control. Every change is a threat. And so we have to study the change, which means patching is really hard. IT comes in and says, why haven't you patched? Guys, the regulator has to approve every patch. We have to prove that the patch is safe before you can put it on there. What do you do with the small shoe factory? Put it on automatic update, guys. I mean, buy insurance, do what the insurer says. So these are very different environments.
Interesting. So you talk about the environment, the scope of who, and the difference between them. Then you start into a path of recommendations. Where does this go from here?
Well, close. Next, I hit threats, because really, I'm assuming there's two classes of readers. There's IT people who are coming into OT, asking, how do I make useful decisions here? There's engineers who are going, I have a responsibility to protect public safety from physical risk, from the risk of earthquakes causing boilers to explode, the risk of hurricanes, taking down power grids and so on. Engineers also have an obligation to protect the public from cyber attacks. And this is, in a sense, new. A lot of engineers have figured this out. A lot of them haven't. So, the next chapter is talking about cyber risk. And I point out that, look, the numbers really have become quite alarming. The last waterfall threat report, what we're observing is that cyber attacks with physical consequences, the lights go out, the factory stops, trains collide. They haven't yet. Those attacks are more than doubling annually. They're increasing currently, but now we have a very small number of data points. So these numbers are likely to change, but the current rate of increase is 10x every 2.5 years, 100x in 5 years. In the year 2027, this is a crisis coming at us. And not a lot of people see this coming. So I point this out in chapter 3. The numbers are there if you want to look at them. This is all in the public record. Okay, there's no private disclosures. And I point out that if, what we have is a crisis coming down the tracks at us, I do not believe personally that we can build a cybersecurity wall big enough and strong enough, fast enough to stop that train. I believe what we have to do is step off the tracks. And this is where chapter 4 comes in, which is talking about engineering grade cybersecurity. It's talking about, in part, the Idaho National Labs Cyber Informed Engineering Initiative, which I very much recommend to all of your listeners if they're interested in the space. And it's talking about addressing cyber risk to physical operations, to public safety, to worker safety, addressing cyber risk as they see it as a coin with two sides. This is informally, not the formal language of the 150-page report. Informally, they see it as a coin with two sides. One side is teach engineers about risk. I try to do that in chapter 3. And, cybersecurity. The other side of the coin is use powerful engineering tools to address the risk of, to the public, of earthquakes and hurricanes and cyber attacks. Concrete example. If you, Christopher, if your life depended on a boiler not blowing up, you're responsible for 6 massive boilers in a coal-fired power plant. You work 8 hours a day inside of the kill radius of a worst-case boiler explosion. If your life depends on a boiler not blowing up, how would you like to be protected from a cyber attack that overheats the furnace under one of your boilers? Would you prefer a mechanical valve where if the steam pressure, there's a hole in the boiler pushed against the valve, if the steam pressure becomes too great, it forces the valve open against a spring, the steam escapes, and there's no explosion? Would you prefer a mechanical valve, or would you prefer a longer password on the computer controlling the boiler? Most of us would prefer the valve, thank you. I've had people say, Andrew, you're asking the wrong question. If this is my life on the line, I want the mechanical valve, or 3 of them, because these things do wear out, and the longer password, and a crap load of cybersecurity beside that. This is my life on the line. And that's the right answer. That's the right answer. But think about it. Where is the overpressure valve in the NIST cybersecurity framework? It's not there. Where is it in ISO 27001? It's not there. Where is it in the industrial 62443 standard for industrial cybersecurity? It's not there. These are cybersecurity standards. The valve is an engineering mitigation for physical risk. These powerful engineering tools exist in the engineering domain. They have no analog in the IT domain. We, for 20 years, we've been focused on bringing IT security into the OT space, and we've been ignoring, most of us, that there are, practitioners who have been using these engineering techniques, but not systematically, not universally. One of the goals of CIE is to unify this body of knowledge and apply it systematically, universally, whenever public safety or worker safety is at risk.
Interesting. So one question I have, and we're going to take a break here shortly, but you mentioned a lot of stats. Can you kind of explain where you pulled those kind of numbers from?
Sure. We went into the public record. Think Google and incident repositories. We went into the public record and we said, how many public reports are there of cyber attacks that caused physical consequences? Not that stole information, not that could have caused consequences, but were defeated before they did, that actually caused outages or equipment damage or worse. Not near misses. So deliberate attacks, not accidents, not errors and omissions. physical consequences in the public record, in the industries that, well, bluntly, we understand. I don't understand hospitals. I do understand, electric power plants and shoe factory manufacturing. So those were the criteria in the public record. So we scoured it. I'm estimating over 10,000 incident reports since the year 2010. And what we saw was for 2010 through 2019, we're bouncing around. How many cyber attacks in the year 2010 met that criterion? There was one. It was Stuxnet. It was 0 in 2011. Lots of attacks, stealing information from power plants. There was 2 in 12, there was 0 in 13, there was 1 in 14, 1 in 15, 1 in 16, 4 in 17, 1 in 18, 5 in 19. For the whole decade, this class of attack in the public record, and in the appendix of the waterfall report, we have a complete list of these things. You can click on them and go to the front page of the New York Times and yourself decide if this was an attack that met the criterion. For the whole decade, this was largely a theoretical problem. Governments were worried, forward-looking industry was worried, but the man on the street said, why are we talking about this? In 2020, there was, I think, if I remember right, 18 attacks. The next year, there was 23. The year after, there was 57. It's only 3 data points, but we're at 57 of these things last year. Does anyone believe we're ever going to go back to a year like 2018 where there was 1? I don't. We've seen a state change in the threat environment. Most of this is ransomware, but 10-15% of it is hacktivists in the most recent data set, the 57. So the world has changed. And this is something I document in chapter 3. And, we, the people who practice cybersecurity for OT systems, we have to take this change into account.
Let's take a break. We'll be right back as we hear from our sponsors. Be right back.
Blockframe Technology offers next-generation blockchain-managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Andrew Ginter, the author of Engineering Grade OT Security, A Manager's Guide. Yeah, hold it up there in the center. There we go. There we can see it. Before the break, you got into where you got a lot of the metrics, and you have some appendices, which be interesting for me actually to look at. I'm a detail person. So now the prescribing part. Where do we go? You're making recommendations. Imagine half the book or the later half is probably on this. Let's give us an index of where you go in the book for there.
Sure. So where to begin? I point out that the engineering profession has an obligation to protect the public. And, I introduced the concept of engineering grade protection. Imagine that the engineering profession has figured out how to design bridges, suspension bridges, much cheaper than current bridges. But these bridges are riddled with harmonic frequencies, the same kind of problem that tore apart the Tacoma Narrows Bridge back in 1940. And so what they've done is implement active hydraulics, vibration dampers, active dampers. AI controls the dampers, multiply redundant. The bridge feels rock solid when we drive across it, when we walk across it, even though it has this problem deep inside the design. How happy would you be driving across that bridge if you knew that the design engineer hoped that we could detect attacks on the AI before they crippled the AI? How happy would you be knowing the design engineer hoped that if we detected the attack, we could scramble an incident response team fast enough to prevent the compromise of the AI? How happy would you be driving across that bridge every day knowing that the design engineer hoped that if the incident response team was not fast enough to prevent compromise, that they could restore functionality of the AI before the bridge tore itself to pieces? Hope is not good engineering. That's not what we expect of the engineering profession. We expect design engineers to design bridges to hold a specified load in a specified operating environment for a specified number of decades with a large margin for error. I talked to an engineer who designs pedestrian bridges. I said, that bridge over there, and I pointed, was a large bridge beside a football stadium. I said, how do you know how much load to put on that bridge? He said, Andrew, there's barriers on the other end. You can't drive across the bridge. It's people only. What you do is you model 2 meters, because most people are smaller than 2 meters, 2 meters of water, end to end on the bridge, the full width of the bridge. That's a shoulder to shoulder load of people on that bridge, he said. And then, he said, you multiply it by 8 and you design the bridge to hold that load, because these are people. Failure is unacceptable. Mm-hmm. And so this is what people expect of the engineering profession. This is not what we've been delivering. It's not what the profession's been delivering into the space of OT security. And so, my prescription is, well, start with the mechanical safeties. Wherever you can, use them. This is, a lot of people have been moving away from them in recent years, thinking they're doing a good thing, automating everything. They're not. You need fail safes. And then secondly, what happens when the valve engages? We shut the plant down, because this is never supposed to happen. The last ditch stopgap to save your life just engaged. You shut the plant down and you figure out what happened, and you change the system so that this never happens again. Here's the thing. The power plant, a large power plant, is critical infrastructure. It's critical to national security. That's what critical means, critical to the nation. We just shut it down. This is unacceptable as well. So when you have unacceptable consequences, you need to prevent the attacks getting into the system in the first place. And this is network engineering. This is what Waterfall does. This is, why I care about this. Network engineering is chapter 5. It's a whole series of techniques between, the old school air gap and modern unidirectional gateways, and about 8 kinds of techniques in between. And I point out that, look, the punchline in, I'll skip the chapter on sort of the theory of cyber risk, which is very different from other kinds of risk. The punchline is, look, if you have unacceptable physical consequences, deploy physical safeties as much as practical. If you have residual risk that is still a threat to public safety, like the lights going out, reliability risks on critical infrastructure, then you must also implement network engineering. And you must do so in such a way as to prevent even nation state grade attacks coming in over the network, because this is the pervasive threat across the network. The ransomware groups, some of them are nation state backed. They have nation state resources. North Korea backs ransomware groups to make, foreign currency because they're sanctioned. Other ransomware groups are just rich enough to afford their own nation state grade tools. The network threat is nation state grade. We need engineering grade protection to prevent that threat from causing unacceptable reliability or safety consequences. So, and on the other side of the coin, the small shoe factory, there's no unacceptable consequences by insurance.
So if I've heard, and I've been listening, since the break, we've kind of talked about engineering and design. Takes a lot of time. I mean, if a solution to security needs started now, when's it available? I mean, what's your thoughts?
Well, here's the thing. One of the criticisms I've had of this book since it released 2 weeks ago is that nothing in the book is new. Safety engineering as a discipline is 50 years old. The network engineering techniques, I point out, the newest is 15 years old. The oldest is ancient. Since the beginning of computing, we've used some of these techniques. And so, cyber-informed engineering, it's not like they're inventing a whole bunch of stuff. What they're doing is gathering this stuff together, because how many people in the world are experts on cybersecurity and safety engineering and reliability engineering, protection engineering, preventing turbines from blowing themselves apart, and network engineering and automation engineering, and you don't find heroes who know all of this. We need to bring it together. we need to structure it so that these people can work together, so that this can become a discipline instead of an ad hoc, meeting of, do we even know who the right number of people are to bring into the room? This needs to become systematic. And so what I'm trying to do here is document that.
Are we just starting this conversation? Are we, it says, I keep hearing we need to. What is happening already that's good?
Well, the good thing is that, these disciplines have all been doing their thing independently for a very long time. Safety engineering, like I said, is 50, 60 years old now. And so all we're doing is saying the tools that you have, use them for cyber risk as well. People have been, beating the drum of cyber risk. Engineers, you got to do more cyber for 20 years, and slowly what we're seeing is really, this is just a new way of looking at things. It is new, but it's a new perspective. It's the same old puzzle pieces. It's just the insight that, guys, they go together this way. And you go, look at that.
Mm-hmm.
Why haven't we figured this out 20 years ago? This just makes so much sense. Of course, we're going to do it this way. This is the reaction I get when I explain these. I just came back from a road trip of large power companies and oil and gas companies, and I explained the threat. I explained the engineering approach, and I explained the logic in chapter 7 where I pull it all together. And nobody said these words to me, but I will paraphrase. They basically said, that just makes sense. Of course this makes, it's one of those things that in hindsight is obvious. I'd like to believe I invented it. I didn't. This is sort of a lot of people coming together on sort of the same target. I hope that I've documented it perhaps more effectively than it's been documented before. But no, these techniques are old. And so when I say new, it's a new way of looking at it. It's a new way to justify, it's a new way to pull it all together.
Yeah. Interesting. Okay. So tell me, what do you do, at Waterfall? Give us a little, what is it that you do? What do you offer? Just a call to action on how people can get a hold of your book too, as well, kind of as we close up here.
Sure thing. So Waterfall is a technology company. We have a support service. We have an install service, but we don't do security assessments. We never take prime on a contract. To deploy a security program. We provide technology that, the flagship is the unidirectional gateway, which is a piece of chapter 5. It's a piece of the network engineering puzzle. It's the most commonly used kind of network engineering to enable business efficiencies like connecting to SAP without the risk of attacks propagating in the other direction. We have a whole family of products that work with this, that either complement the gateways or are based on the gateways. And we work with the world's most secure, most cautious industrial enterprises. Most often, rail switching, power generation, power transmission, refining, petrochemical pipelines, heavy industry, steel mills we have. We're starting to see data centers doing their OT using our stuff, because I'm sorry, if the power drops on the data center, you've lost 1 million CPUs. You've critical information infrastructure has just been crippled because somebody attacked your power transformer management system. If you would like a copy of the book, Waterfall is currently giving them away in celebration of the launch. Where is it? There it is. Engineering-grade-OT-security. Go to waterfall-security.com/engineering-grade-OT-security. Ask for a copy. The threat report that I mentioned, go to the Waterfall webpage. There's a section called Insights. Click on that. There's like an ebooks and white papers, and you scroll through that. You can get the threat report. I did not copy the entire threat report into the appendices. What I did was I copied chapters 3 through 6 of the Black Book into the appendices. I fly high and slow for most of the book, but then in Appendix B, I reproduce the entire methodology from the Black Book. So you don't have to buy the Black Book. If you read the gold one and you like it, you've already read the heart of the Black Book. But Appendix B dives down and goes fast. It's much more technical.
Well, thanks so much for being on today. I definitely appreciate it. And I know it's very timely. A lot of people are engaging. The OT security programs are usually our best performing, and we hope to get you some awareness to your material as well. So thanks for joining.
indeed, thank you for having me. And I, if I may, I'm coming up on the end of my career. I might have 5 years left, give or take a couple. If this is my last shot at producing something, I hope I've been persuasive, and if I haven't been persuasive, I hope it's at least useful.
Yeah. And I think we all are looking for that giving back. So thank you so much. We appreciate it.
Thank you. Take care.
Bye.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.